Hello learners, I am Keerti Bhave from Sri Bhagubai Mafatlal Polytechnic, Mumbai. Welcome to the session on corrosion. Today, we will be studying corrosion, its types and mechanism. After studying this topic, you will be able to define corrosion, distinguish between the types of corrosion, and explain the mechanism of corrosion. Let us begin with the technical definition of corrosion. Corrosion is the loss or decay or destruction of the metal because of the action of surrounding media. Corrosion can also be defined as wear and tear of the metal because of environment. The words surrounding medium and environment are very important here. Depending upon the nature of the surrounding medium, corrosion can be classified into two types. Atmospheric corrosion, when the surrounding medium is gaseous, and immersed corrosion, when the surrounding medium is liquid. Liquid most often is water. Now, at this point, I want you to take a pause and think, why at all are we studying this topic? What is the need for us to know about the mechanism of corrosion? Take a pause, write your thoughts on a paper, and then come back. Now let us see whether your thoughts match with what is the truth. Corrosion is an undesired phenomenon. Billions of dollars are lost each year due to the loss of metal because of corrosion. Another few billions are used up in research and towards prevention of corrosion. To find out the cure, we have to know the cause, and therefore we have to reduce corrosion, and we have to understand how it happens. That is, we should know the mechanism of corrosion. Atmospheric corrosion is also called as direct corrosion, chemical corrosion, or dry corrosion. Atmospheric corrosion, as the name suggests, is because of the atmospheric gases. Out of all the gases present in our atmosphere, it is the oxygen which is responsible greatly for atmospheric corrosion. And nitrogen and inert gases do not cause atmospheric corrosion. What is the mechanism of this corrosion? It is a simple chemical reaction between metal and oxygen. Metal and oxygen together combine to give you metal oxide. This oxide may be unstable, it may be volatile, or it may be stable and non-volatile. Let us see if the metal oxide formed is unstable oxide. Metal plus oxygen gives you metal oxide. Because this metal oxide is unstable, it decomposes into metal and oxygen. Apparently, we do not see the metal getting corroded. Obviously, in such cases, the rate of corrosion is very low. This happens in metals like gold, platinum, or palladium. The other extreme is when the oxide is volatile oxide. Metal plus oxygen forms metal oxide. But this metal oxide is volatile. That is, it evaporates. And thus, it exposes a fresh layer of the metal. In such cases, the rate of corrosion is extremely high. In between these two extremes lie most of the metals, whose oxides are stable and non-volatile. That is, the metal oxide is formed, but it does not get evaporated. So where does it go? It remains on the surface as a film. Now, depending upon the size of the metal oxide molecules, like here, the metal oxide molecules are larger as compared to the metal atoms. This metal oxide film, which is formed at the surface, is non-porous. It is impervious to the oxygen from the atmosphere, does not allow the entry of oxygen once formed, and therefore acts as a protective barrier. And in such cases, the rate of corrosion is low, like in aluminium or nickel or chromium. The other kind of oxide is when the molecules of metal oxide are smaller as compared to the metal atoms. They are also stable and non-volatile, but the film formed at the surface is porous. There is gap between the molecules, and through these pores, the oxygen from the atmosphere gains entry into the metal lattice, thus corroding it. In such cases, the rate of corrosion is extremely high, as in copper or silver. Now let us see what we have done today. We have studied the definition of corrosion, which says corrosion is the decay of the metal because of the surrounding medium. Then we went on to the types of corrosion, which is there are two types of corrosion: atmospheric corrosion and immersed corrosion. And then we studied the mechanism of corrosion and how different metals corrode at different rates. Thank you. Happy learning.